I would like to dispose of a few things very quickly because we have a long road ahead of us, long road. Holomorphic functions, what are they? They're functions that can be differentiated by complex number z. In other words, functions that satisfy Cauchy-Riemann relations. And here are a few examples. I'll just make a little library of them for future use. Constant. So function of z is just a complex number. Identity. The function of z is z itself. Polynomial. Of some finite order, presumably. Whenever you have a polynomial of order n, you can always write it as some kind of constant in front and then z. Product of n roots. Where the roots are complex numbers. And this is now called fundamental theorem of algebra. So next come rational functions, which is just ratios of two polynomials. You take derivative of upstairs minus the derivative of downstairs, and there is no problem in taking that. Now, next one is a little more delicate. Power series. And power series, unlike polynomial, doesn't stop. Now, these are complex coefficients. And when we deal with power series, we have to make sure that they are convergent. What does it mean for a series to be convergent? So convergent sequence of complex numbers an, n goes from 0 to infinity, or maybe 1. So the series is said to be convergent if it has a limit a for all n larger than some n star or something. So for any epsilon, there is a finite an such that distance to the limiting value is bounded. A sequence is said to be Cauchy convergent for any given epsilon. The difference of any two consecutive terms where n and m are both larger than some n star is smaller than epsilon. A sequence converges if and only if it's Cauchy. This is notions for sequences. Now consider series. In case of series, we take infinitely many ANs and add them up. A partial sum is given by a finite sum up to term AN. Convergence series converges only if sequence of partial sums Sn converges. Absolute convergence. If series of absolute values of terms converges, then series A1 plus A2 plus A3 plus is said to be absolutely convergent. Now notice absolute convergence is much stronger than convergence because if you add a bunch of complex numbers, their phases might interfere. So for example, phases could be plus and minus 1. So a series could converge, but its sum of absolute values doesn't converge. So absolute convergence is a strong state.